The overarching framework for all of our work is to try and diagnose patients with cancer at an earlier stage, and the focus of our laboratory is really cancer of the esophagus and stomach. And we study this because it's really the ideal paradigm to understand the evolution of cancer right from the earliest pre-invasive steps, which in this disease is called Barrett's esophagus, through to a fully blown cancer. The reason that this is such a good model, if you like, to study, or an exemplar, is because these patients with precancerous Barrett's are actually monitored serially over time, so we can get samples over space and time from these patients to really do a very detailed examination of what's driving the steps towards invasive cancer. And the other thing that's really given us unprecedented opportunity in the last 5 years or so is all the explosion of sequencing technology, which means that we can now study in the resolution that we weren't able to before exactly what's characterising those steps as you move towards cancer. And we've done this as part of the International Cancer Genome Consortium, which has been a tremendous opportunity. We're a very clinically focused lab. I'm clinically trained as a gastroenterologist. We have a very wide interdisciplinary team, and what really motivates us is to take this in-depth knowledge into the clinic. And so, as well as understanding, we've actually been using this information to design new molecular assays and new diagnostic tests. And I guess what we've done most work on, what's got farthest in the way to the clinic, is developing a new tool called the cytosponge, which is very simple in its concept. But this enables you to get a fantastic cell sample, but in a very simple, non-invasive way that could be applied in a GP surgery. And then in the lab to apply some of that quite detailed, sophisticated knowledge in a molecular assay to diagnose the patient. And not just to diagnose Barrett's, but to tell whether the patient is at low risk of cancer or high risk of cancer. So we go all the way from the in-depth basic understanding of the disease, from patient tissues into model systems, and then to designing diagnostics which we can put into clinical trial.